Temperature is a measure of the average kinetic energy of the particles in a substance or a system. Kinetic energy is just the energy of motion, so it is basically a measure of how fast the particles in a substance are moving. The higher temperature particles have more kinetic energy and they move faster. Lower temperature particles have less kinetic energy and they move slower. So that's a little bit different from heat. Heat is the energy that's transferred between substances or systems, or you can think of it as being transferred between a system and its surroundings. Heat always flows from hot to cold, so from warmer systems to colder systems. Now here's an example of temperature versus heat. Here's a pot of boiling water. The temperature is the average kinetic energy of the water molecule, so how fast those water molecules are moving around. The heat is the energy transferred from the stove to the pot, so from the hot system to the cooler system. Okay, so the heat capacity is the energy required to raise the temperature of substance 1 degree Celsius. We are going to use a specific heat capacity, which is C, and that is the energy required to raise the temperature of 1 gram of substance by 1 degree Celsius. Okay, so the units for that is joules, again, the amount of energy, per gram per degree Celsius. Every substance has its own specific heat capacity, or C. The specific heat of water is 4.18 joules per grams degrees Celsius, which means it takes 4.18 joules of energy to raise 1 gram of water 1 degree Celsius. I've also got the molar heat capacity here, and that's the energy required to raise the temperature of 1 mole of a substance by 1 degree Celsius. So the units are a little bit different. It's joules per moles degrees Celsius. Okay, so now let's talk about Q equals MCAT, or how to calculate the amount of heat that's transferred from a system or to a system, or from a system to its surroundings. Okay, so Q is the amount of heat, that's in joules. M is for mass, and that's in grams. C is the specific heat capacity, which is in joules per grams degrees Celsius. And delta T is the change in temperature, and we are going to calculate that using the final temperature minus the initial temperature in degrees Celsius. Okay, so our first example problem says how much energy is required to raise 50 grams of water from 80 degrees to 100 degrees Celsius. And we are going to use Q equals MCAT to calculate that. We're going to solve for Q and plug in the mass, the specific heat for water, and the change in temperature from 80 degrees to 100 degrees Celsius. So this next problem says, what will the final temperature of 100 grams of aluminum at 10 degrees Celsius and 50 grams of water at 90 degrees Celsius be after you mix the two substances together? So notice that the aluminum is at a cooler temperature and the water is at a warmer temperature. Now once you mix these two together, energy is going to be transferred from the hot system to the cold system until they are at the same temperature. Okay, so to solve this problem, we are going to use Q equals negative Q. And what that means is the amount of energy that the hot system is losing is the same amount of energy that the cold system is gaining. So our hotter water is going to lose the energy. That's an exothermic process for the water. And our cooler aluminum is going to gain the energy, which is an endothermic process for the aluminum. So I'm just going to indicate that our aluminum will gain that energy, and the water will lose that energy. But again, it's the same amount of energy that's being gained and lost, that's being transferred. Okay, so once we have our Q equals negative Q, we can use MCAT equals negative MCAT and plug in the mass, specific heat, and initial temperatures for both substances and solve for the final temperature that both substances will reach at the very end. This final problem says 50 grams of metal X was heated to 80 degrees Celsius and put into 50 grams of water at 25 degrees Celsius. So again, we have two substances. One of them is hotter. In this time, the metal is hotter. And the other one is cooler. This time, our water is cooler. Now this problem says the final temperature of the two substances was 35. So in this problem, our final temperature is given, but we're being asked to solve for the specific heat of the unknown metal. Okay, so you're still going to use Q equals negative Q, MCAT equals negative MCAT, except for this time you are solving for one of the C's, the specific heat capacity constants. Okay, so try this problem out, pause the video, and at the end I will write down the answer for you. Okay, so our last problem says 50 grams of metal X was heated to 80 degrees Celsius and put into 50 grams of water at 25 degrees Celsius. So again, we have two substances at different temperatures. This time our metal is our warmer substance and our water is our cooler substance, okay? So the metal is the one that's going to be losing the energy and the water is the one that's going to be gaining it. It says the final temperature of the two substances comes out to 35 degrees Celsius. So in this problem, we're given our TF, but we're being asked to solve for the specific heat of the unknown metal. Okay, so you are going to use Q equals negative Q, MCAT equals negative MCAT, but in this case, we're going to solve for C, the specific heat of your unknown metal. Okay, so pause this video, work out the problem, and see if you get C equals 0.929 joules per grams degrees Celsius.